WZFG, Dilworth, Fargo, Moorhead, USA. It's 8 o'clock.
And welcome to our winter special, our winter outlook for this winter. Joining me is Chief Meteorologist Gary Lezak from down in Kansas City, Justin Storm, meteorologist here at Flag Family. And welcome, gentlemen.
Yeah.
How's the night going? Good evening, Gary.
Forward to our discussion and hey, we're still a month away from winter, but you guys are already getting some winter weather up there.
A little bit. Yeah, we had our first snow of the season last weekend and picked up about 2 inches of snow here in the Fargo Moorhead area. A little bit more up to the north towards Grand Forks. They picked up about 3 to 4, and they had a little bit more off into northern Minnesota. But most of that's melted around our area. But hopefully more is on the way. I know a lot of hunters enjoyed that fresh snow for last weekend, deer season. That was the second week of deer season up here, so that helped them a lot. But a lot of people are hoping for some much colder weather so we can get that ice forming on the lakes for ice fishing later this year.
It has been a warm start. It really has been. It's something that's going to be interesting for us to discuss because where is cold air?
That's right. Yeah. And, we've got La Nina to deal with this year. We've got, we're going to go into depth here about the LRC. And Gary, why don't you start off telling us what is the LRC and how did you stumble across this, or how did you come upon thinking, hey, wow, there's something to this? What is the LRC for people out there that are listening, watching that have no idea? We've never heard of this before.
I definitely stumbled across it. It was the year 1987, 1988, perhaps a few years earlier than that, when I was at the University of Oklahoma getting my degree in meteorology. Some students there, a good friend of mine, said that maybe it was earlier than 87 and 88, but it was the winter of 1987 and 1988 that I discovered that weather patterns were cycling. You're looking right now as the LRC is the centerpiece of this big atmospheric puzzle. And over 35 years of my own research and experience and prediction, I realized that the LRC really is the centerpiece. These other factors, ENSO, which is La Nina this year, as you know, the MJO, Madden-Julian oscillation, PNA, AO, NAO, are all influences and forces on what's happening within the westerly belt across all the northern hemisphere and likely the southern hemisphere as well. I just haven't studied the southern hemisphere much yet. But the pattern is cycling regularly. In 1987, 1988, we had a 1-foot snowstorm in Oklahoma City. Officially, it might have been less than that, but where I lived, it was about a foot of snow on the north side of Oklahoma City. A foot of snow in Oklahoma City. Wow. In places, they average 8 inches of snow a winter. All right. And so that was impacting. And then it was active. It snowed that November before that big snowstorm. It snowed in March at the end of that winter. And in the middle, about 40, 50 days later, there was another 1-foot snowstorm. And I looked at the weather patterns that created the snowstorms and the other storm systems, and they seemed to look similar. So it was about then I went, maybe it's not a coincidence that these storms are related. Within the same season, you have 2 1-foot snowstorms. You have 30 inches of snow that winter, whatever, in Oklahoma City. It was crazy winter. And that's when I realized the pattern was possibly cycling. Over the next 5 years, get to 1992, I noticed more. I learned more. And by early 2000s, another 10 years later, I knew more, and I started the blog at KSHB.com, and I started a blog there. And the bloggers named it the LRC after me, for Lezak recurring cycle. So whatever it's called, I just call it the cycling pattern hypothesis, the LRC. We can call it that. But it's fascinating. And about 4 years ago, I wrote a paper. It was peer reviewed. You can Google it, Cycling Patterns of the Northern Hemisphere, and a new hypothesis. And I explained La Nina, El Nino, and how the LRC is like is the centerpiece, because there was a big El Nino, I believe, 2016, 2017 winter, followed by a big La Nina or moderate La Nina the next year. And when there's an El Nino, California is supposed to get very wet. That's what the statements are. But that year, I noticed within the LRC, within the weather pattern cycling above us, that there was a big block off the West Coast, and it prevented storms from coming into California. And so it was very dry when all these forecasts for mudslides and extreme wet conditions out in California were for that year. The next year, La Nina, it was supposed to be a continuation of the drought out there. And instead, it was one of the wettest years ever, because the LRC set up in such a way that Southern California, got blasted,
Right.
even in a La Nina, which isn't supposed to happen. So anyway, I found it then, and then got the peer review paper published, and now we're making real accurate predictions. So the LRC works like this, Dean and Justin and all of you out there. There's three main aspects to it. One is that a unique pattern sets up every fall, right around the end of September and early October. And then so a unique pattern sets up, a pattern that's never happened before. The pattern we're experiencing now has never happened before. That's aspect number one. Number two, anchor ridges and troughs become established. These anchor ridges and troughs, the troughs will be where storm systems reach their peak strength most often, and the ridges will be where storm systems weaken and maybe get deflected away most often. So they become established for the entire season, all the way through the next year into September. And then most importantly, a cycle develops. A cycle length develops. Last year's cycle was about 46 days, 46.3 to be exact, but 46 days. And once you know the cycle, and there's a big storm in North Dakota, we can tell you when it's most likely going to return regularly. And so that's how the LRC works, guys.
Okay. Now, Gary, got a question for you. One of our viewers just emailed this in. Why does the LRC start in early October? Why does a new pattern start then? Why not late October or early November? Why is that time period so critical?
It's been through my observation that it has, but I got another hypothesis, is that the sun sets at the North Pole and on the autumnal equinox. So this year on September 23rd, the sun set at the North Pole. So every year there's one sunset at the North Pole every year, and there's one sunrise. First day of autumn, first day of spring, that's when the sun rises at the North Pole. But it stays twilight for about 12 days or so to 2 weeks. So October 5th, 6th, or 7th, it finally goes dark at the North Pole. We have twilight for about an hour at 45 minutes. And then at the North Pole, they have twilight for like 12 days. Then it goes dark. Right about then is when there has to be some astronomical reasons and forcings that are creating, helping create the cycle. And by the way, astronomers are the best forecasters in the world. Here's a shout out to all of you astronomers out there, because we know that the Earth tracks around the sun once every 365 days, or a 365-day cycle. The Earth rotates on its axis once every 24 hours for a 24-hour cycle. And so these cycles exist in astronomy, and astronomers are so good, they can tell us in 30 or 40 years exactly when an eclipse is going to happen down to the second, and they will be right. The lunar eclipse coming up Friday morning, they will be right on exactly when it starts. They know what exactly it's going to happen, because up there, these cycles are perfect. But our cycle, the LRC, within the westerly belt, and it influences the polar easterlies and the tropics are also intertwined in this. So it's a whole atmospheric circulation that's cycling regularly. But it's a fluid, so it oscillates a little bit. It's not exactly 46 days. It might be 44, 45, 46, 47, 48, 49. And it oscillates, but it's still regular enough where you can make predictions. But it's probably an astronomical reason. That's a long answer.
Right. That's okay. Is there an easy way to explain to our listeners, how do you calculate the cycle length each year? Do you take what the weather pattern is in and around October 6th, the upper level weather pattern, and wait for that similar pattern to show itself again, and then that's the cycle length? Is there an easy way to explain to our listeners how the cycle length differs each year and how you establish that?
Well, this year, right when the pattern began in the first week of October, North Dakota got hit by a major significant storm system.
Big one.
It was really large, and it put a big dent into the drought conditions you guys have been experiencing up there. And when a feature like that is so big, we will be able to identify that feature in the next few cycles. And when we see that part of the pattern return, we'll say, hey, that might be it. And it might be 50 days later. It could be 60 days later. I don't know yet. We're still in the first cycle of this year's LRC. We have not gotten into the second cycle yet, although I have a strong inclination to think it's going to be around Thanksgiving weekend when we're going to start cycle number 2. But we'll see. But so that's one way, through qualitative analysis of the patterns. But quantitatively, we can figure that out by looking at what I've created as the LRC index, and we take the 500 millibar heights, and we've created an index for locations all over the world. And there's a very subtle difference between last year's 46-day cycle and other possible cycle lengths. And the correlation coefficient goes in favor of the 46 or 47-day cycle just slightly. But so mathematically, it has to be proven because, or at least shown, because it does exist. So mathematically, it will show. But a lot more research needs to be done there. But I have done that. We in my peer review paper, we picked 3 different years and showed quantitatively how to find the cycle,
right,
whereas qualitatively is where you can do it by looking at the maps.
Right. I'd like to thank all of our listeners and viewers out there. Hey, if you have any questions for me, for Gary, for Justin, shoot us a call, 701-271-1100. That's 701-271-1100. Or you can email your weather questions to weather@flagfamily.com. This winter weather special tonight is brought to you by Prairie Supply. Is your job site prepared? Secure your season heat rentals today at Prairie Supply, the contractor's headquarters. And Gary, it's, this LRC, I've been following this with you for a number of years. I've tried hard to turn a lot of my peers onto this. Justin Storm here, who just started with us about a year ago, dove in and did a lot of statistics that we'll get on later. But he's hooked. I've got some peers in the National Weather Service that I'm trying to turn on to this forecasting method as well. And I think, how fast is word spreading? Are people accepting this, or is this kind of like, there's no way he can be that accurate? How is he doing it when the computer models that we have right now, like the GFS or the European, I mean, a week out and things change. Our short-term models, if you will, they can't even get it right. So how can you explain, outside of the cycles, that, how can you let people know, like, hey, this is real, and we should all start to be using this to get more accurate forecasts out there?
Well, we should, and it's going to be the way of the future. I am convinced of it. It goes up against conventional methods. This is why my peers are they're going to be behind, and I've been trying to share it for 20 years. It is really complex. But the GFS model, the European model, example would be the Chiefs played the Indianapolis Colts in a playoff game 3 years ago now, I believe it was. And there was a 10-inch snowstorm here in Kansas City, where I live now. And that was related to a blizzard we had 45 days or so earlier. I think it was a 47 to 48 day cycle that year. And 47 and a half to 48 days earlier, there was a blizzard in November. So I identified the pattern at being 47 to 48 days. So I knew and predicted that there would be the blizzard part of the pattern returning around January 12th, that weekend. And that just happened to be the weekend the Chiefs played the Indianapolis Colts. And a week before, 10 days before, the computer models had sunny, no sign of a storm. So when you look at the GFS and the European model, and there's no sign of a storm for Thanksgiving weekend, the GFS model just came out with nothing for Thanksgiving weekend. But I believe there's going to be a potential significant storm system in the middle of the country around Thanksgiving weekend. But I'm not convinced yet because I don't know exactly what this year.
Yeah.
But that year, 5-6 days before, the model still had sunny and 50. And I'm on the air saying that's the snowstorm part, the blizzard part of the pattern. Snow is likely. And 3 days before, all of a sudden the forecasts were for snow. And then 2 days before and 1 day before, snow likely. We ended up with 6 to 10 inches of snow during tailgating of that game. But so what the LRC does, it allows us to know when the GFS model is right and when the models are wrong. So if it doesn't fit what we know is going to happen, then you can say, hey, that model is wrong. And it allows us a level up and a big edge in forecasting long range. And our model that Justin can talk about here, I'd like to bring him in because he's done an analysis on the model data I provided to you for last spring, I think it was. But the model, our model is as accurate. The 100-day forecast, the 150-day forecast from our computer model, the LRC computer model that we have, is as accurate as day 7 is. So you have a 7-day forecast, you see your 7-day forecast, you look at it on your app, you watch it on television. Our 100-day forecast is just as accurate as that 7-day is.
And if memory serves me right, Justin, why don't you tell Gary? Justin, he's a number cruncher, and he was going through Excel and he was just crunching the numbers from last year's LRC. And Justin, why don't you tell Gary what and everybody else out there what you found out from last year's LRC?
All right, so I took some numbers that we got here in the FM Metro for the amount of precip that we received from the beginning of October to the middle of November. And in that time period, we picked up 1.2 inches of moisture.
Because last year was a 46-day cycle. Yep. Is that correct, Gary?
A little over a 46-day cycle. Yeah. So over that 46 days of that first cycle from October to mid-November, we picked up 1.2 inches of precipitation or snow, melted equivalents, and rain. So using just that first cycle, I extrapolated that out over the next 3 cycles to come, which would bring us into the second week or just before the second week of April. And just based on the amount of moisture that we received in that first cycle, you'd expect that you'd see 3 times that amount of moisture over 3 cycles to come, which would be 3.6 inches of moisture. And we picked up 2.54, which gives us 75% accuracy on it. However, you shouldn't look at it exactly that way because over the winter, the air holds less moisture in the air. So you're not going to get that full 1.2 inches over the winter simply because the cold air can't hold that much moisture in it. So instead, the way that I looked at it is that we fell 40% below average for that first cycle over that time frame that we should have received amount of moisture. We should have had 1.93 inches. We only had 1.2. So over the coming 3 cycles, that would be from the middle of November into the beginning to middle of April. Over that time frame, 40% of that average should have been 2.45 inches of rain, and we received 2.54, giving the LRC simply based on the first cycle a 96% accuracy on the amount of moisture that we received. And the other thing that's super interesting about that is you forecasted, or that's just using the information from October. So that's forecasting 4 months in advance simply based on how much moisture we received in October and November based on how much we should have gotten.
Right.
And then to go even further than that, as you went throughout the summer and into the upcoming new LRC, which we're in right now, you had forecasted months in advance that we were going to have a hot, above average summer with a couple of heat waves and about half the amount of precip that we usually have. And that's exactly what this summer was. It was very hot. We had heat waves that you had down to, the entire week that heat wave was going through. You had that down to the day when it would start and to about where we would see those temperatures at, as well as the entire part of, July heading into June, or June heading into July was just hot. And we received about half the amount of precip that we usually would have in that time frame. So it blows my mind because when Dean first came to me with this LRC that you had come up with, I was like, no, there's no way. You can't forecast 7 months out in advance and tell me that it's going to be, remotely accurate. And, I just kind of put it on the back burner, and I was observing as it came through. I got some of the graphics that you had sent over to us, and I followed them pretty closely. And, they were spot on throughout the entire last year within the LRC. I would have given it about a 90% accuracy rating, several months in advance for what the entire year was going to look like. And, I'm really looking forward to what this coming year is going to bring as well within the LRC to see if it's just as accurate.
Right.
It's likely going to be just as accurate. I really appreciate that analysis, Justin. But yes, there are seasonal differences. For example, there's going to be a major snowstorm sometime in January, let's say, in an Arctic blast. Well, in July, when the pattern returns and cycles back through, it's not going to be an Arctic blast. It's not going to snow. So you will have seasonal differences. And so a temperature that is like, let's say you have one of those cold outbreaks and you're 28 below zero or something like that. You're going to have one of those stretches sometime this winter, although there's no sign of it yet. That might be 30 degrees below average. But in July, you're not going to be 30 degrees below average. You might be 12 degrees below average. So there are seasonal differences that we've incorporated into our LRC model. And by the way, the company that we have that runs that model is weather2020.com. You can go there, weather2020.com, to learn more. But that's pretty good analysis.
Right. We just got a viewer question in here. It says, so this is from Dan. Dan says, so with the LRC, can we get a more concrete 10-day outlook forecast? Let's say now you say there could be rain 10 days from now. With the LRC, can you say there will be 1.5 inches of rain in 10 days?
Predicting the exact amounts might be difficult. It comes down to the forecaster that takes a look at upper level flow and 500 millibar charts and what that pattern would look like when it returns, and knowing what it will look like in January. For example, a strong storm in January that's ripping out into the plain states may create a surface low 2 states out ahead of it over Illinois, and you get a tornado outbreak in the southeast, perhaps, even though the storm is coming into North Dakota. That same storm could come in June, and that surface low will be closer to that upper level flow because the flow is a little bit weaker loft. So predicting the exact amounts it's possible, and we are working on doing that. And for example, that snowstorm example I gave you, we predicted there would be a significant snowstorm, but when it comes down to the amount, we still use the conventional models when we get within 3, 2, and 1 day to come up with the exact amounts. But we can come up with a rough amount for the season. Like Justin and Dean, I provided you the LRC model data that did have amounts on it. So yeah, we can go week by week and give you amounts of precipitation with our model.
Right. We had another viewer send in an email here, and he said, so far this season, we've had a lot of wind storms. I mean, we've had, North Dakota and Western Minnesota, we're known for wind up here, but we've really had some pretty large storm systems with a lot of wind. He asks, can we expect this throughout the rest of the winter using the LRC?
Yeah. I did an analysis this year compared to last year, and it's an interesting analysis. Basically, since October 5th or 6th on day 1 of this year's pattern, let's just assume that day 1 was October the 5th. From that point till now, November 17th, North Dakota has had 12 systems, ridges and troughs, 9 impacting troughs and 3 ridges. A year ago, in 2020, you had 4 impacting troughs and 4 ridges. So you had 8 systems going by North Dakota, whereas this year it's 12. So we have a good 50% increase over last year. So in other words, a much more active pattern, and with 9 troughs going by, that means you're going to have, and with all these systems going by, you're going to have the pressure gradients that will cause the wind. So you're going to have wind. It's going to be much more active. And it's not just North Dakota. Most of the United States is about to have a very, very active winter and spring season ahead, because I had that same result for almost all locations, even from Boston to Kansas City and from North Dakota to Seattle and back to San Francisco, even in the South, an increased activity over a year ago. So it's a much more active pattern already in this first cycle, and that is going to continue, if that makes sense.
Right. So let's use an example, Gary. So approximately, I think, Justin, it was it 3 days into the first cycle?
Yeah.
Where we had a monster storm here. We were on the warm side of it, and I think we picked up, a little over an inch of rain.
It was day 4 of the cycle. We picked up an inch.
Okay. Wow. So it was, and it was a huge windstorm. And I believe areas of the far western part of the state got hit with snow. So if we extrapolate that out, let's say that was 4 days into the first cycle. Once the cycle resets, let's say it does reset, we start cycle 2, as you were saying earlier. Let's just assuming we start this Thanksgiving weekend. Is it safe to say then, using the LRC, that 4 days after the cycle resets, we're going to have a storm very similar to that mammoth storm that hit North Dakota and Minnesota and South Dakota as well?
That part of the pattern will cycle back through. Will it produce a storm exactly the same? Well, it probably won't be exactly the same. It'll be different. And will it be weaker in this cycle? Maybe. Will it be stronger in this cycle? Maybe. That's something we're going to have to experience. But in the next, let's say it's a 50-day cycle this year. So October 10th, you had the significant storm. So November 10th is 31 days. December 10th is 61 days. So right around December 1st, November 30th, that part of the pattern will cycle back through. And then 50 days later, around January 15th to 20th, it'll cycle back through again. So one of those two cycles absolutely has a very good chance of having a storm similar and with a lot of wind, blizzard potential. So that's something to look for. It doesn't mean it happens in every cycle, but that storm, that was so strong, probably so. I did an analysis also. This year in October, you had 3.35 inches of rain in Bismarck, 7,300ths a year ago in October. So you had 3.35 inches this year in October, 7,300ths a year ago. And up till now in November, last year and October and November, you had 9,700ths, and you're at 4.08, I believe. Maybe it's 3.6, but whatever. You've had a lot more precipitation. Right. So the potential for drought this year, even though it's another La Nina, is still is a lot lower.
Right.
And I'm not 100% making that call yet, but it looks like the chance of drought in North Dakota is much less. You should have enough rain for the crops next spring.
Which is great news for our agriculture community, boy.
Hey, Gary, I just had another question come in here from Keith. He wants to know, why doesn't the GFS or Euro or other long-range models like those pick up on the cycle?
Those models are physics-based models, and they're really sophisticated programs. And ours is a statistical-based model, so it takes what's already happened, and it has algorithms that are going to not compound errors. In the GFS, the European, the NAM, all the other models out there that are physics-based, which they all are, the errors start compounding hours after the model is run. And sometimes 1 day to 2 days later, the errors are so significant that the models are already worthless. Now, the models have gotten better. And so 1 and 2 and 3 days out, they're pretty reliable. At 7 days out, they're often unreliable because of the compounding errors. Our model doesn't have those compounding errors. And that's what allows our model at 100 days out to be as accurate as a 7-day forecast is.
Okay. And Gary, we have a caller. Is it Keith? Kevin's on the line. Kevin has a couple of questions for you. Go ahead, Kevin. Thanks for calling.
No, I can hear you in the background.
Okay,
Hey,
can you
Kevin.
hear us?
Hello.
Yeah, go
John?
ahead. Go ahead, Kevin.
Good. I just had a question. If his model, am I on there?
Yep.
I can't hear you.
You're
Yes, you're on the
Okay.
air.
There you go. Good. Thank you. I just had a question. If his models and his theories took into account, say, the wobble, the axis of the Earth, if it takes into that, or even sunspots.
No, it does not take those parameters into consideration. Could those have some impact on our weather? Likely some. I think it would be very minimal on a storm by storm basis, but it does not take those conditions into consideration.
Okay. Thank you, Gary. Thank you, Kevin. We're going to take a quick 30-second break here for our sponsor. And again, you're listening, watching to our winter weather outlook. If you have any questions for Gary, myself, or Justin, shoot us a call, 701-271-1100. Again, that's 701-271-1100. Or you can email your questions to weather@flagfamily.com. We'll be right back.
Pouring concrete in the winter comes with many unique challenges. Fortunately, Prairie Supply has the equipment and knowledge to keep your job site on track. With year-round delivery and service from 5 convenient locations across the state, it's never been easier to contact Prairie Supply, Inc. for temporary job site heat, curing blankets, and ground heating units for winter weather construction. Prairie Supply, Inc., the contractor's headquarters.
Welcome back. Again, you're listening and watching our winter weather outlook with Gary Lezak. Gary is a chief meteorologist down in Kansas City at KSHB, and we're talking about the LRC. The LRC is a specific way to forecast long-term weather. And Gary, I was sharing with people how accurate your LRC prediction is. And why don't you go into a little explanation of this past LRC season with the hurricanes down on the Gulf Coast, because this when I saw this on your Twitter feed, it was amazing. And I said, you've got to be kidding me. He got this down to the day. Why don't you tell our listeners about that?
Yeah, thanks. It was about 10 years ago when, 35 years ago, I discovered the LRC. And by the way, 40 years before me was Jerome Namias. Here, I'm on a tangent, guys. I'm on a tangent.
That's all right.
40 years before I even had any idea that the pattern might be cycling, Jerome Namias, he was the head of the long range forecasting division for the National Weather Bureau, now the National Weather Service, in the 1940s. And he wrote a paper called the Index Cycle, and he wrote a couple hundred papers that were peer reviewed, believe it or not. And he suggested that by November, there's enough information to accurately make a projection of what's going to happen the following winter. Ding, ding, ding. That's one part of my theory. Okay. And then he said anchor troughs and ridges exist. And he also talked about how an index cycle, as he called it, lasts for weeks at a time. But he didn't ever get to the realization that the entire weather pattern is cycling regularly. I mean, I have peers in meteorology. Okay, so there's cycles, but it is not regular. It's chaos. There's no way. No, it is complete order to the chaos, and that's what the LRC is all about. So, what was your question again?
We were talking about the accuracy of the LRC and how accurate it predicted the hurricane season.
So about 10 years ago, we knew there was a system coming towards Florida, a hurricane. Forget which one it was right now. I forget the name of it. And it was heading towards Florida, and AccuWeather and other forecasting, the Weather Channel, all thought it was going to come right into Florida, up into the Gulf of Mexico, but on the Florida Panhandle. And we used the LRC by understanding the pattern and the cycle length that it wasn't going to Florida. It was going to keep moving west because it had to fall into the place of the system that had happened in other cycles near Texas. And it ended up missing Florida. It went all the way into the Gulf of Mexico, intensified, and then came right into where we thought it would go. So that was 10 years ago. Fast forward to the last 3 years, and we've been getting increasingly accurate. Hurricane Ida, Justin had talked about our 7-month prediction by our model. How about a 7-month prediction of a hurricane? We predicted back in January that there would be a likely named storm coming into Louisiana around the end of August. And Hurricane Ida followed a similar track to, I believe that was either Delta or Zeta. I can't remember which one it was off the top of my head, but
I think it was Zeta.
Okay, yeah. Zeta on the left, Ida on the right. And Ida took a similar track. So that prediction that we made using the LRC, we were able to predict it striking Louisiana down to the date. Now, sometimes we're a day or 2 or 3 off, but we're able to predict tropical storms and hurricanes down to the date. All right. This is Zeta, Claudette, and Nicholas. So no, that one, the other one was Delta. This is Zeta. Hurricane Zeta, when that happened last year in October, around the beginning of the LRC, we knew right then, almost 300 days before, that there would likely be another named storm tracking into Louisiana. Claudette then formed in June. And when Claudette formed, we were able to make the prediction of a stronger named system that would happen in one of the next 2 LRC cycles, and Nicholas formed right on schedule. And Nicholas was going to take a track very similar to Claudette and Zeta, but it formed 2 days earlier than we thought, 2 days earlier. And that's why it took a little track to the west, which is great news because New Orleans had already been hit by Ida. They didn't need to be hit by another one.
Right. We've got a viewer question, and it's Devin. Devin asks, how does all the weather modification going on affect your weather predictions? Do you take in any weather modification into the LRC, Gary?
Well, with climate change, the weather pattern that's cycling above us in the troposphere is not really affected by climate change. As the Earth warms or cools, whatever the cause is another story. But as the Earth warms even 1 or 2 or 3 degrees, the jet stream is created by temperature contrast. So as the temperatures get colder right now across northern Canada, near the North Pole, and then down into southern Canada and down into your area in the northern plains, as the temperatures get colder and colder and colder, the temperature contrast from 30 below zero to 90 degrees in Texas becomes 120 degree contrast. Whereas during the summer, you have 75 degrees in Canada and 95 degrees, 100 degrees in Arizona or whatever. It's only 25 degrees of contrast, and the jet stream weakens. So the jet stream is created by these temperature contrasts. It's caused by the thermal wind, and the jet stream will get stronger and stronger during the winter. So even with climate change, with a little bit warmer climate or a little bit cooler climate, 100 years from now, who knows? But even with climate change, the LRC is not impacted by that. The pattern's still going to be cycling regularly.
Right. Okay. And we also had a caller. He called in, I guess didn't want to be on air, but he said, can you give a quick recap on what the LRC is? And basically, it's a weather pattern. Gary coined this, invented this, however you want to say it, but it's a cycling pattern that occurs. It sets up in early October, and it varies in length. It could be 40, 45, 50, 60 days. And once that first cycle is set, it repeats itself throughout the year into the next fall season. So, Gary, I'll tell you what, it's the accuracy is absolutely great on the LRC. And I'm hoping that, by getting the word out there, this will not only get more people on board with this, but it will also give the public more accurate forecasts. I mean, and who doesn't want that? We could save lives with these hurricanes, knowing in advance where these hurricanes are going to hit, where these blizzards may hit ahead of time. It's amazing. And like I said, hopefully we can get the word out and everybody likes a more accurate forecast. I think we can all agree to that. And with the invention of computer models and how that has advanced over the years, weather forecasts, and a lot of people will say, man, you guys got the greatest job in the world. You get a paycheck and you're only right 50% of the time. That's a good one to always hear. But
that's ridiculous.
Yeah, I know. In actuality, I think we know, and most people do know, that the weather forecasting technology has really improved over the last 20 to 30 years. And this is just another, as you said, piece to the puzzle that is really going to advance the way weather is forecasted.
This year, for example, Kansas has had 46 tornadoes this year, a whole bunch of which, about half of those, came in October. So up until October, until this new pattern set up, it was very quiet in Tornado Alley. Parts of Tornado Alley have still not had a tornado watch. Parts of the Kansas City metro area have not been under a tornado watch in over 2 years. Okay. May would be 3 years for parts of the Kansas City metro area without a tornado watch.
That's crazy.
Kansas had 46 tornadoes this year. The pattern changed and set up, and it's still evolving at this moment in late September, early October to now. It started producing tornadoes in Tornado Alley again. So I can make this bold prediction right now. 46 tornadoes this year in Kansas. We can more than double that. Next year, 2022, there will be 100 or more tornadoes in Kansas. All right.
Wow. Very active year.
And that's after 2 straight years with almost no activity in Tornado Alley. That's from West Texas, Oklahoma. Oklahoma's been very quiet until this October. And then, so that's one prediction I can make. And for North Dakota, as it's more active, what do you guys, Justin, have you made a prediction yet for the snowfall?
I've kind of dug into it a little bit with some of the numbers, and I'd be really interested to see in what you have come up with, or some form of a range. But I think it was within that about 58 to 70 inches of snow. Or I had run number that was 76, and the last time I ran it, it was about right around 60 inches of snow.
Wow.
And I went, so our normal snowfall up here is typically right around 50 inches. Last year we had 30 inches. So we were well below normal, obviously, with the drought conditions too last year. So we're having a little contest here at work. And so Justin went, 50?
So this was before. This was a while back ago, and I went with 48 inches of snow.
Okay. I predicted, and I'm assuming that through the cycle we had 2 decent sized storm systems come through here in that first cycle. So I kind of took that into account, and I went 57.9 inches.
Wow.
Which is just a little bit above normal.
Yeah.
We have 2 more systems.
What's that, Gary?
57.9.
57. We're getting right down to the 10th.
Well, what's really weird that happened with that the first couple strong storms you had in October, where you got a lot of rain. Usually that would be snow, even in October for you guys, wouldn't it be usually?
So I mean, and that's why we're hoping that we have enough cold air. Now with the snowpack building in southern Canada, it's going to be a lot easier for that cold air to drain down.
Right.
Thankfully, there was no snowpack up in Canada to speak of during the month of October.
And that's one thing that happens within the LRC. This first cycle has had very little cold air, and there's a couple parts of the pattern that may develop cold air, and there's also something significant that has happened over Greenland, way up in the northern Atlantic. That's where the NAO index, the North Atlantic Oscillation, that blocking high that you have there, that upper high has been forming up there from time to time since this pattern began. One other year was similar to this, 2007, 2008. So I go look and see what happened that year for North Dakota. I'm not big on analog years. I believe the LRC is all about this year is unique, and this year's pattern is cycling. But there's probably still some similarities, and it's only 2007, 2008 in the last 20 years that was even close to having this kind of blocking up there. So I'm anxious to see how much snow you guys had. Kansas City had a lot of snow that winter, so we'll see.
Right.
But
Right.
but I think what happens is once the cold air gets down into the pattern, it might not leave. It'll go back and forth from Canada down into the United States, but it hasn't been there in the first cycle. So until it gets there, it might limit your snowfall totals. I still think you're going to have a very big spring with snow. And so I'm going to go a little bit above average and go with 62 inches for you guys.
All right. 62 inches. Okay. Is Kyle still on all right. We've got a caller, Kyle. Kyle, go ahead with your question for us.
All right. First off, can't hear you guys, but we can try and figure that out. But out of the rhythm, I kind of heard you a little bit in the background. Just want to say, first off, Gary, I've worked with Dean for now the past about year or so. And it's really, really awesome to hear someone that actually knows a little bit more than him talk. So that's great. That being said, man, I heard 62. I was going to ask the question everyone, of course, is going to ask at some point here about what you thought. And I wanted to ask, usually from what I heard from Justin and Dean, 70 to 80% effective, maybe. Any chance you can be in that 20% for me so I can win this bet we have?
Of course, we could be wrong. By the way, my 62-inch forecast is just based on what I'm seeing in the pattern, my own meteorological mind that's predicting that. The model, we have a model that runs, that is global. We have a global model. So, because the pattern that's cycling here is cycling across London, England to Beijing, China, all the way across. So our model is predicting precipitation, but not necessarily snow. So I'll get you that forecast from our model for North Dakota. But yeah, it could be wrong. I hope not.
Okay, Gary, we've got another caller, Steve. Steve is on the line. Steve's got a question about this upcoming winter. Go ahead, Steve. Steve, are you there?
Hi.
Okay.
Hi, Steve.
Yeah, I'm right here. Am I on?
Yep. Yeah,
yes.
Go ahead.
Okay. Question about summer of 2022. Are we looking at a stormier than average season or not?
The pattern that we're in now is going to continue to cycle through summer and into next September before it starts and another unique pattern sets up next fall. So most likely the answer to that would be yes. But on that one map we showed earlier, on the first 30 days of this pattern and how very wet it was, 300% of average for North Dakota, now you're a little drying out a little bit. So this first cycle has a good 20-day stretch of, as you can see on that map there, the first 30 days of the pattern, very wet across the Dakotas. That was very good news. The last 30 days, so it's dried out a little bit. So there's probably a wet phase and a dry phase. And as we identify the cycle, we'll be able to know when that wet phase will cycle through and when that dry phase will cycle through. Right. So I don't have that yet because I don't know the cycle length, but we'll identify it soon. And then we can pick out which weeks will be wet and which weeks will be dry. But this pattern will continue in the summer.
Right.
Gary, I got a quick question from a couple of emails here. Tim wants to know, how many days in advance can the LRC predict the intensity of a storm such as a blizzard, or is the factor only realized a day or two before the storm strikes?
The intensity of storm systems can be predicted, but the predictability isn't as good as some of these other levels, like you're saying 80%, 90%, 96% accurate on some of these parameters. When it comes to intensity, maybe the accuracy, it's there, but maybe it's lower. Maybe it's a 55 or 60% accuracy on our own analysis on how strong a system might be. With hurricanes, for example, at this point, I can tell you that there's, out of the 9 named storms that made landfall on the United States this year, 8 of them we predicted would make landfall. But did we know the intensity of Ida? Did we know the intensity of Nicholas? Did we know the intensity of Fred and Elsa and these other ones that developed? I would say no. Given when you know one's going to happen in around September 10th, the peak of hurricane season, the chance of it being stronger is higher. But we can identify the strength of systems as we go through. So you just experienced this first cycle with these strong storms in North Dakota. The probability of you having wind, especially as we go towards late winter into the spring, is probably extremely high that you're going to have these windstorms.
Right.
But
and I believe we have another caller on the line. Aaron, you've got a question for us. Go ahead, Aaron.
Aaron, you there?
Aaron, are you there?
Yes.
Okay, go ahead.
Yes, I am.
You can ask your question.
Forgive me. I've kind of been in and out of the conversation, but I noticed you're talking a lot about precipitation. But do you have any thoughts on the temperature? Is it going to be bitterly cold or colder than ever?
I'm going to make an assumption here, and please let me change my mind on my assumption here in a few weeks. But Justin's 48 inches of snow, he might want to adjust it. But Justin, go with your first instinct. Just stick with 48 inches and see what happens. But
we're stuck in that one.
But I'm gonna right now. There's very few parts of this pattern that are capable of producing the brutally cold Arctic air. So we really haven't had that yet. That blocking, though, that has happened is more likely to happen again as we go towards January and February in the peak of the jet stream. So I would say probably one or two really cold outbreaks, and then the rest mild. So it may end up being a little bit above average on temperatures. But let's see if a big Arctic air mass forms between now and Christmas. There's just no sign of it yet.
Gotcha. All right. Let's take a quick break, guys. We'll go to our sponsor here real quick, and then we'll come back and dive in a little more. We're going to try and squeeze a little more info on our upcoming winter weather out of Gary. And so we'll be right back.
Pouring concrete in the winter comes with many unique challenges. Fortunately, Prairie Supply has the equipment and knowledge to keep your job site on track. With year-round delivery and service from 5 convenient locations across the state, it's never been easier to contact Prairie Supply, Inc. for temporary job site heat, curing blankets, and ground heating units for winter weather construction. Prairie Supply, Inc., the contractor's headquarters.
We're diving in deep on what our winter weather forecast looks like. Joining me is Chief Meteorologist Gary Lezak. He invented and has his own specific computer model. He uses the LRC. It's a cycling pattern that sets up in the fall in early October, and it goes and it varies in length each year. If you're just joining us, and it's a cycling weather pattern that is it's 70 to 80% accurate, even higher as we get a little further into the season. So, Gary, so North, South Dakota, Western Minnesota, temps on average below normal for the most part. We will have our mild streaks as we've seen so far in this first cycle. It's been kind of a roller coaster ride. Can we expect that roller coaster ride through the rest of the winter?
Yeah, characteristics of La Nina tend to be temperature extremes, and we do have a La Nina, which is cold, the cooling of the tropical Pacific Ocean. It is growing in strength a little bit right now, and it may likely impact the winter. It will impact the winter. So usually you do get more temperature extremes. So once we get the Arctic air to build up, we're going to have some ups and downs. I'm also looking, I just called up the model. I haven't done this yet. For December 1st through January 31st, I call up our proprietary LRC model from weather2020.com, and it has 3.3 inches liquid in southeast North Dakota during that 2-month stretch. Is that wet for you guys?
Yes.
So 1.7 inches liquid in northwest North Dakota.
Okay, so a little drier in the northwestern part of the state.
But still 1.7 inches liquid in December and January during the cold months. That's still significant. That would be
So
17, 20 inches of snow, you know.
Right. And you had what, 3 point in southeastern part of the state?
3.7.
Okay. So, I mean, you extrapolate, if that all fell as snow, that'd be about 30 inches there. A little bit more maybe. But so temperature wise, going to kind of be up and down. Snowfall prediction. Okay. Our normal snowfall, what would you say is going to be our snowiest month? We're going to try and pin you down here, but snowiest months.
I haven't studied North Dakota. What is your snowiest month typically?
Justin, you could with February, March.
Usually into March, we usually get hit with at least one, big winter storm in March every single year. Anyone up here would know that.
Right. So let's say, let me do a little calculation in my head. October 10th to 20th, you were very active. So that would be around December 1st, around January 20th, perhaps. So right around March 1st. March, that big, huge storm, if it isn't rain again, could be just a major system in March. So you should have one big one in March and then a few other ones during the winter. So, but we're still learning more. The LRC is still evolving. We're in cycle 1. We need to get to cycle 2 so I can identify that. And by the way, for all of those of you listening, thanks for listening and opening your mind to this new technology. And it usually takes until about the 5th of January to really nail down what that cycle length is. And if you can nail it down like 46 to 47 days like we did last year, that's what allows us to predict down to a specific date when something might happen. We could be a day off, 100 days out. If we're a day or 2 or 3 off, that's good. If you're 3 hours off the next day, that's good. So 100 days out, 3 days off, we're in that window of accuracy.
And Gary, I've been keeping track of this quite a bit in a little Excel thing. And, we've kind of mentioned a couple of times we're thinking about this pattern recycling around Thanksgiving. And based on what I've been reporting so far in this data file is about 4 days after that cycle restarts, we should be looking at the potential for another large-scale system, followed by a second one possibly 4 days after that, followed by about a 2-week dry area with the potential for a third system, followed by another about 2 weeks of dry before our fourth system. And we've kind of had those 4 major systems in our area over this first wave of the LRC. Does that sound about right to what you've been seeing?
Your analysis is right. So let's find out when we believe the second cycle begins, and then you can start making those predictions. And then you can look at the model and go, hey, why isn't it showing up on the GFS? Because the GFS is wrong.
Right. Okay. Well, and again, this is our winter 2022 outlook. This winter prediction special is brought to you by Prairie Supply. Is your job site prepared? Secure your season heat rentals today at Prairie Supply, the contractor's headquarters. Gary, we're going to go past the top of the hour if that's okay with you. If you can stick around here for a while,
they'll page me in about 4 minutes.
Okay.
I gotta get out there and do this promo.
Not a problem. Well, let's start wrapping this up then. So a snowier than normal winter for the northern plains. Temperatures kind of up and down. And again, are we looking at after March? Are we looking at an early? Because I mean, it snows here into April and such. Are we looking at an early spring after March?
Let's identify a little bit more if this Arctic air gets down here. If it does not, then it's going to be an unusually mild season because there's just no sign of that yet. But possibly, but that wouldn't be totally characteristic of a La Nina winter either. So I just think that the extremes are going to happen. So it may start early, and then all of a sudden you're going to get a cold blast.
Great. Now, Gary, we had another question here. Where can where can somebody, George asks, where can I find these LRC forecasts?
Weather2020.com. All right. Go to weather2020.com. There's our website. And I blog at kshb.com. So go to KS as in Sam, HB.com. I work at KSHB 41 News as well. And tomorrow I'll be blogging about that Thanksgiving storm. So you can go there and read about that. And I occasionally blog. You can go to the Weather 2020 blog too and learn a little bit more about what we've done with these hurricanes, the Tokyo, Japan Olympics forecast. Our model pretty much predicted the tropical system that came in there. So you can learn a little bit more about that and stay in touch. You can also email me if you want to. My email is gary@weather2020.com.
Excellent, Gary. And I think we have one more question, Justin.
Yep. Nate had a question. He's watching us over there on YouTube. He's a storm chaser, and he says, is there any chance that storm chasers can also use the LRC model months in advance so they can help out with the warning processes while in or out of state?
Absolutely. I mean, we have predicted severe weather outbreaks months ahead, weeks ahead. The day 4 to day 8 severe weather outbreaks that the Storm Prediction Center says are experimental still, our 50-day and 100-day outlooks that we can put out are as accurate as those are. So yes, I can, if you're planning a chase vacation that goes tornado chasing, I don't want to come with you because I don't like tornadoes. I've seen one. That's all I ever need to see. But yeah, we can have Weather 2020 probably should develop that product that we can have as well. So, but yeah, we can let you know which week is going to most likely be the most active weeks when the outbreaks are going to happen.
Right. And once we get this cycle set, Gary, which is coming up very soon, we will be able to pinpoint, Justin and I, when these storms are going to hit our area, North and South Dakota into western Minnesota. So make sure you follow us on our Facebook, our social media pages. Once we get this cycle set, which is going to be close to Thanksgiving weekend, then we're going to be able to predict a little more accurately when the bigger snows are going to hit. And it looks like, this winter is going to be, I've been telling people, much different than last winter. 30 inches of snow last year was very mild. We did have a cold stretch, about 10 days, 14 days. It was brutally cold. But yeah, this looks more like a typical Northern Plains winter, which I'm sure a lot of snowmobile enthusiasts, skiers,
that'd be great.
Outdoor activity.
Will the lake trees, though? Will the lake trees? They better, right?
Yeah, it's going to be a much better winter for them.
Dean, what you just said, what you and Justin just said, it's amazing. You're saying that with confidence. You that you're going to provide the insight to when these systems are going to happen. And it's not perfect. We're predicting the future. There's no doubt about it. But it works.
And I think the good news too, Gary, is, again, for our agriculture community, the spring looks a lot wetter than it was last year. So obviously we don't want too much rain in the spring. We don't want any flooding, but this looks like a much more promising forecast using the LRC for this upcoming year for all of the agriculture community as well.
Absolutely.
Yeah, which is great news. Well, Gary, thank you so much. I know you've got to run. You've got a job to do there. And I want to thank you, Gary. Thank you, Justin. I want to thank all of our listeners out there and viewers. Thanks for tuning in. Hopefully you got a lot out of this. I love talking to Gary. He's a great guy, fantastic meteorologist, and extremely accurate. Follow that LRC. Follow Gary at weather2020.com. And again, this should be an exciting winter around here.
It definitely is. I'm looking forward to it. And we'll have, again, more information on our pages about our local weather and what the rest of the winter will be looking like as soon as this cycle recycles here over the next about around that Thanksgiving time. We'll have a better idea.
I think early December around here is going to be really exciting. So again, thank you to everybody out there. Gary, thank you so much for taking time out of your evening to help us out here and explain what the LRC is. So until next time, thank you for listening, and be sure to follow us on our social media pages.
Thank you.